interventions. And we will now move to our final panel of the day that Romany has conveniently helped set up for us, which is the critical issues of monitoring, reporting, and verification. These are obviously issues that are pertinent to all of the carbon removal options that we could possibly conceive of, critical both in terms of their role in voluntary carbon markets and regulatory markets. And one of the areas in which this may prove most daunting is in the context of emerging ocean-based carbon removal approaches, and both in a context that may be more germane to domestic options, such as in coastal areas, but also in the open oceans. And so we thought a panel that discusses where we are in terms of MRV in the ocean and where we may have to be in the future and how we may get there, I thought would be pertinent. And so we have a great panel to help discuss this. And with that, I will turn it over to Ignacy to begin the panel. Thank you so much for joining us.
It's a pleasure being here tonight, or this afternoon, tonight for me, from Europe, and moderating this panel, which, as you just said, we will be addressing some great challenges about measuring, reporting, and verifying CO2 removal in the ocean, because the ocean, the world needs the ocean CDR. So we have to face those challenges and find out how to do that, and basically, or additionally, find out how the business community can interact and can play a role in that. So for discussing this topic, we are lucky enough to have three great panelists with us. On the one hand side, we have Molly Holmes. Molly Holmes is the founder and CEO of Submarine. Submarine, a benefit corporation building computational climate models to make carbon drawn down possible and safe. Molly, thanks for joining us. We also have with us Liz Kinnessy from Vera. She's the manager of food and blue carbon innovations, and she's responsible for advancing Vera's food system and blue carbon innovation work streams. Liz, welcome, and thanks for joining us. And last but not least, we also have with us Kelly Earhart. Kelly Earhart is the president and co-founder of Project Vesta, which is a project for harnessing the power of the oceans to remove excess carbon dioxide from the atmosphere. So, ladies and gentlemen, thanks for joining. The floor is yours. We should start probably by Molly.
Thanks. Let me share my screen. Can you guys see those slides okay?
Yeah. That's full screen, correct. Go ahead.
All right, so the oceans can store a lot more carbon than the land can. They are a carbon reservoir about 10 times as big as the land. And whereas the land typically, or terrestrial approaches in general, barring DAC, can typically store carbon for decades, the oceans can typically store carbon for centuries to even millennia. But CDR in the oceans is risky. It does not come with all the obvious co-benefits that soil and forestry do. It is hard to commercialize, it is hard to govern, and it's hard to quantify. One thing that has become clear to us is that scientifically, we do know how to quantify it. We're not there yet, but we know theoretically how to do it, and the tools are available. These are really the harder problems. But I think that we will find that all of them need to be underpinned by good quantification. So I just want to go through really quickly an example of what it takes to quantify carbon drawdown in the oceans. So kelp is a good example. You can grow kelp at the surface of the oceans, you can sink it to the seafloor, and in theory that sequesters the carbon in the kelp. But over time, and sometimes quite rapidly, the kelp will degrade. That CO2 will be released along the ocean floor, where it can stay out of the atmosphere for, potentially centuries. But for example, if you're near an upwelling region, the circulation of the ocean will bring that carbon back up to the surface where it'll be re-released into the atmosphere. So upwelling can limit the permanence of the drawdown. And then additionally, when you grow biomass at the surface, it doesn't pull CO2 from the air, it pulls it from the water. And so what you result in is a spreading plume of CO2 depleted water that over many thousands of square miles and over months or even years gradually pulls down CO2 from the atmosphere. But that CO2 depleted water has to stay in contact with the atmosphere for that to happen. So if you're near a downwelling region, or there's a lot of mixing in general, the CO2 depleted water can be brought out of contact with the atmosphere. And so downwelling can limit the scale of the drawdown. And these are processes that take place over huge regions of space and time, and they can't be measured directly in a lot of cases. So you need modeling, as Romany said, to quantify them. It's very similar with alkalinity addition. If you have a point source of alkalinity, for instance, using electrochemical methods, the result is a spreading plume of alkalinity. And as long as that alkalinity is in contact with the atmosphere, it gradually leads to an air seaflux. But again, downwelling can cut that process short. So you have to be able to model the circulation of the ocean in that entire region. This is a movie that our partners at NCAR did. It simulates a point source of alkalinity addition in the Santa Barbara Channel. And you can see this is just the spreading plume of alkalinity as it gradually diffuses over several months. So that entire process leads to drawdown, but it's over a huge area and over a huge period of time. So we can quantify these things, but at any given point in the ocean surface, the actual air seaflux that's happening is tiny, and it's often against a huge background process. So you need lots and lots of data from multiple sources, from satellites, from the existing ocean observation network, and ultimately from hardware like sail drones deployed at project sites. You need to assimilate that data into high resolution regional models, and ultimately you can get a quantification, but it's a complex process, and uncertainty levels at first, until we get higher and higher resolution models, will be pretty high. There's also the question in all of these cases about ecological impact. So if you're sinking kelp to the ocean floor, you're disrupting benthic ecosystems. You are also, in addition to sinking all of that carbon, you are sinking all of the nutrients in the kelp. So that's going to have cascading impacts on multiple layers of the ocean ecosystem. And if you're growing biomass at the ocean surface, you are, potentially outcompeting all the other life there. So that has ecosystem impacts. It also means that the kelp is potentially replacing phytoplankton ecologies that themselves could have been sequestering carbon. So you have to do really complex additionality calculations to make sure that the intervention you're making is actually adding to the total carbon sequestration. So in our view, ecological impact assessments shouldn't just be an add-on to MRV. They need to be part and parcel of it. And to do that, quantification protocols need to require that you have coupled ecosystem models coupled to the physical and biogeochemical models that you use. So all of this can seem pretty complicated, and I think it is more complicated than individual projects can do, but we know how to do it. It's really integrating the science into the regulatory and market structures that that I think are the thornier problems. So even if we know how to do good MRV, there's no regulatory requirement for it. We are maybe many years away from a regulatory structure where MRV is demanded. What that means is that now we are dependent on market forces to demand good MRV. And I think that in general, that's not how markets work. Markets want things to be cheap and fast. And, you know, we're at a unique point in the carbon removal markets where a lot of very good actors are thinking really hard about how to structure things. So we have a chance to structure a carbon removal market that does demand good MRV. I don't think that's mostly happening. I think that the legacy markets did not demand good measurement. And I think that the new carbon removal markets are duplicating a lot of the things that went wrong in the legacy markets. I think we would all benefit from a really good postmortem on how quantification worked in the legacy market, so that we make sure we don't recreate those problems. The biggest ray of hope I see is that right now, the actor with the biggest clout in the carbon removal markets is Frontier. They have $1 billion advanced market commitment in place, and they just released a lot of documentation going into detail on how to quantify uncertainty in carbon removal projects. And they made an explicit call for pricing uncertainty into carbon removal credits. And if that kind of template can be laid for the market, it's really powerful, because ultimately it will drive a market demand for quantification. And then ultimately, I think the hope that everyone has is that when there's a regulatory structure in place, if we lay a good foundation, they will adopt it. So there's sort of a fantasy at work here now that we could have a carbon removal market where MRV has inherent value. That is definitely not the case at the moment, but I encourage everybody to have a look at the uncertainty mapping work that Frontier did with Carbon Plan, because it's sort of I think the best approach that we have on the table right now. And I will leave it right there. Thank you.
Thank you so much. Several questions for discussing afterwards. May I leave the floor now to Liz on behalf of Vera to see the approach of the certification.
Yeah, thank you so much for the invitation to be here today. It's been great to listen in on so many interesting panels. If you just give me a moment, I'll go ahead and share my screen. All right, can you see the PowerPoint? Yes, okay, cool. Thanks, Will. All right. So today I will be chatting about challenges and opportunities to enable voluntary carbon market finance for ocean-based CDR activities. My presentation will cover two main objectives. The first will be to provide an overview of the current status of coastal and marine opportunities under Vera's Verified Carbon Standard. And the second will be to highlight key challenges and opportunities that we have identified that prevent the development of ocean-based methodologies. And so to get started, I wanted to provide a little bit of background on Vera, the organization that I work at. We are a nonprofit that was started back in 2007. We have an office in Washington, D.C., but at this current stage, we have staff really all over the world. And the main activity that we do at Vera is to develop and manage standards that track progress towards achieving different climate change mitigation goals and sustainable development goals. Pictured here on the slide are the various standards that we mentioned, which I'll just give a little brief summary of. Our largest standard is the Verified Carbon Standard, which is our flagship program. The VCS is the world's leading voluntary greenhouse gas program. We also have a jurisdictional and nested RED framework, which is basically an accounting and verification framework for RED programs. RED refers to reducing emissions from deforestation and degradation. We also support the state of California with its compliance offset program, and we actually operate an offset project registry under the CARB. In addition to those standards, we have a climate, community, and biodiversity standard, or the CCB standard. We like acronyms at Vera, so I apologize in advance if I'm using any acronyms. The CCB is a multiple benefit standard, which is used to certify projects in the land use space that goes beyond just measuring carbon. We operate the Sustainable Development Verified Impact Standard, or SD-VISTA. This standard is used to certify a project's impact on Sustainable Development Goals, or SDGs. I want to point out that both the CCB and the SD-VISTA can be used in conjunction with the Verified Carbon Standard, or they can be used on their own as standalone certifications. Our newest standard is the Plastic Waste Reduction Standard, which aims to support and scale up activities that increase plastic waste recycling. And then lastly, we are involved with Landscale, which is a collaboration with other NGOs like Rainforest Alliance. And Landscale is essentially a global standard that allows for an assessment of an entire productive landscape. And so that's just kind of a high level view of all the different standards that we operate at Vera. But I want to go into a little bit more detail on our verified carbon standard, because I think that's the one that's most relevant for the discussion today. As I mentioned, it's the world's most widely used voluntary greenhouse gas program. And the program essentially ensures the credibility of GHG emissions reduction and removals by laying out different rules and requirements which all projects must follow in order to be certified. The program includes the VCS standard itself, which is a set of rules that are applicable to all projects under Vera's system. We have a system of independent auditing where all VCS projects are subject to a field and desk audit by an independent third party known as a validation and verification body, or a VVB. We have a set of accounting methodologies which have different steps to quantify the greenhouse gas emission reductions and removals based on different types of project activities. So for example, we have a methodology for improved forest management, and we have methodologies for improved agricultural land management, to name a few. And then lastly, we have an in-house registry system which contains transparent information on all registered projects and all of the verified carbon units, or VCUs, that have been generated by any given project. And so that's a little overview of the VCS and what it actually contains in order to verify any emission reduction or removal that gets generated. And then I want to give a little bit of information on our current approach, looking at blue carbon, which to us refers to any carbon that is stored in a coastal or marine environment. Currently, the VCS covers coastal blue carbon activities, or the conservation and restoration of mangrove salt marshes and seagrasses. We have 3 approved VCS methodologies that are applicable to coastal blue carbon. We have 11 blue carbon projects registered, and we have a little over 10 projects that are currently under development and in our pipeline. But all of these projects are only pertaining to coastal blue carbon areas. So in addition to these established coastal blue carbon opportunities, there's been increasingly growing interest in ocean-based activities to reduce or remove emissions. And those include activities like seaweed and kelp farming, kelp forest conservation restoration, seaweed sinking, seabed management, and ocean alkalinity enhancements as well. And in response to this growing interest in these ocean-based activities, Vera, along with Sylvestrum Climate Associates, decided to create the Seascape Carbon Initiative, or the SCI. The members of the SCI are depicted on this slide. They compose the steering committee of the SCI. The main goal of the Seascape Carbon Initiative is to assess and then prioritize different ocean-based opportunities that can reduce and or remove greenhouse gas emissions and help to mitigate climate change. And the SCI aims to identify key research questions that are not only related to the carbon sequestration potential of these different activities, but rather to specifically filling gaps that prevent crediting these opportunities under the VCS. So answering questions that pertain to methodology development, for example. And we think that by filling in these gaps, the SCI will be able to drive forward changes to the verified carbon standard itself to be able to enable ocean-based activities, and then to also promote the development of greenhouse gas accounting methodologies for these ocean activities as well. So overall, the main goal of the SCI is to drive forward climate mitigation at scale by accelerating research that can realize social and environmental benefits, by driving demand in the market, by facilitating methodology development, and then also facilitating piloting of projects following these new methodologies on the ground as well. Now I'd like to get into the second part of my presentation and touch on some of the challenges and opportunities to enable ocean-based voluntary carbon crediting. Working with the SCI, we have identified key questions, both research-based, which are in the green box, and then some questions associated with the program itself, which are in the blue box. We have identified these as the main questions that need to be answered in order to be able to develop any sort of ocean-based carbon crediting methodology. Each of these questions really bears a lot of relevance to the measuring, reporting, and verification requirements contained within the verified carbon standard itself. And I think that these questions, while they present many challenges, could also present some opportunities as well. The first question that I'd like to cover is whether we can robustly measure the relevant greenhouse gas sources, sinks, and reservoirs. So this is important because for any activity to be creditable, we need to be able to quantify the greenhouse gas fluxes, the carbon stocks, and then the offsite greenhouse gas impacts or leakage associated with that activity. The quantification needs to also be accurate, transparent, and conservative in keeping with the rules of the standard. And so while this is a quite large challenge, there are many rapid developments in ocean sensing technologies that could potentially help overcome these measurement challenges. With increased attention being paid to ocean CDR, there's a lot more data available from which we could potentially develop models, which could then inform default factors. So for example, it might be possible to conservatively estimate a carbon sequestration potential for seaweed farming based on the farm's geographical location or perhaps on the underlying substrate of the farm. A second question, and Mowgli kind of touched on this as well, is whether there are potential unintended negative impacts from ocean-based interventions. And so we need empirical data to actually be able to assess the unintended impacts of ocean activities. And further, there is a need to develop a process to then be able to monitor for these impacts. Again, quite a large challenge, but perhaps also could be a way to highlight ways to mitigate or reduce these unintended impacts of ocean-based activity, and could also potentially help to move forward some sort of code of conduct for ocean-based activities as well. Another key question is, can we monitor the greenhouse gas impacts of an intervention through the course of a project in a way that is both cost-effective and verifiable? Monitoring of ocean-based activities can be costly, and it can be challenging even just to logistically reach an area where an ocean-based intervention is being implemented. And as I mentioned, the verified carbon standard requires that all projects are audited by an independent third party. So a key consideration on top of just the normal challenges you're thinking of in terms of monitoring projects is whether those project activities and their impacts are then auditable by an additional party within this space. Again, while a challenge, there could be an opportunity to develop auditor trainings that focus on ocean-based activities, and then to also recruit new stakeholders who are already active in the marine space to become auditors under the verified carbon standard. Now I want to get into some of the program-related questions. Currently, under the verified carbon standard, we have a tool in place for our AFBOLU, or agriculture, forestry, and other land use projects. This tool is used to essentially assess the risk of non-permanence and then address that risk through a contribution into a pooled buffer account. However, we would need to translate this tool to ocean-based activities, since right now it's really only considering terrestrial and coastal areas and ecosystems, but ocean ecosystems present new challenges. For example, is there a difference in the risk of non-permanence in carbon stored in deep sea environments versus nearshore environments? What are the risk factors that we need to take into account, like sea level rise or increasing storm events? All of these might impact the permanence of the carbon that is stored. Again, there could be an opportunity to expand this tool that we already have to include ocean-based considerations, covering both natural and non-natural risks to projects and their long-term carbon storage. Moving on, there are also legal and policy implications that we've identified that need to be resolved in order to be able to generate credits in the ocean space. Currently, the verified carbon standard requires that any project proponent must demonstrate that they have a legal right to control and operate their project activities. So moving into these open water systems, who can claim ownership of carbon credits that are generated in international waters? And further, who is liable for these activities 100 years into the future? Could we potentially, though, use existing mechanisms like the London Protocol or the International Seabed Authority to go ahead and determine ownership of carbon credits that get generated from these activities, and then to perhaps even promote governance of these ocean activities in a way that perhaps has been lacking to date? This is an area of active research at Vera, and we'll be working on this over the coming months to try to really tease apart what the different legal implications might be of these open water activities. And then lastly, I want to just touch on environmental and social safeguards, which is another key question that we've identified. Currently, the VCS requires that project activities shall not impact the natural environments or local communities. And while we have this no net harm rule, do we need to develop additional safeguards that are specific to ocean-based activities? So going beyond just limiting those unintended environmental impacts, we also want to be sure that there are no unintended impacts on livelihoods or, for example, impacts on fishing yields because of some sort of intervention that's being implemented. And again, trying to be a little bit optimistic because these challenges are so great. It could also represent an opportunity where if we can get the appropriate safeguards in place, perhaps we can actually go ahead and promote the many co-benefits of ocean CDR, like building new blue economies, increasing food security, and also helping to conserve biodiversity. So while there are a lot of questions that need to be answered, if we can respond to all of these knowledge gaps that we've identified, there is an opportunity to be able to leverage voluntary carbon market finance to help promote activities in the ocean, help mitigate climate change, and hopefully to also promote the different co-benefits of these ocean activities at a meaningful scale. And that is all from my end. Stop sharing.
Thank you so much, Liz. You certainly raised couple of hot topics and questions. I was outlined the topic of ownership and those collateral effects that also Molly mentioned in his presentation. But let's give the floor to where you, Kelly. To Kelly, so we can close the interventions. Please, the floor is yours.
Thank you so much. Thank you for having me. Great presentations, Liz and Mowgli. And thank you so much for setting the stage in a comprehensive way. I'm Kelly Arhart. I'm co-founder and president at Vesta, where we are developing coastal carbon capture. Excited to talk to you a little bit about our path as a company to develop a method for MRV and what our challenges and opportunities have been. But first, I'll just introduce you a bit more to what we're doing. So we are advancing ocean alkalinity enhancement using olivine minerals. And what that means is from a high level, we're accelerating Earth's natural process of rock weathering, which is pictured on the left-hand side of the screen here. We're accelerating this process that normally would take millions of years and taking the part of the process that draws carbon down out of the atmosphere and into the ocean to be something that can happen over the course of decades instead of millions of years. So specifically, we use olivine sand. We grind olivine minerals into a carbon removing sand and then bring that sand to coastal areas where it dissolves with the help of wave energy and tides. As the olivine sand dissolves, it generates alkalinity in the form of bicarbonate, and that catalyzes the carbon dioxide removal reaction. One thing to note here is that one of the key ways we're bringing coastal carbon capture into the world today is by working with shoreline communities in their adaptation response to sea level rise and erosion. Whereas shoreline protection is becoming an increasing need for these communities to protect and replenish their coastlines, we're able to work with them and either replace a portion of the sand in these projects with olivine sand or add it as an additive to these projects to try and make them carbon negative. So I'll share a bit more about that process in a moment. But to dive a bit more into exactly how it works, this is the chemistry, primarily, the magnesium silicate is added to the water, and that is what drives the reactions on the bottom here, which result in the reduction of acidity, turning carbonic acid into bicarbonate that's stored for thousands of years. That bottom equation there is the fundamental chemical basis of Earth's carbonate silicate thermostat, and is what's helped stabilize our climate for billions of years. So we're working to understand how we might be able to accelerate that part of it. And this kind of fundamental relationship between the the release of these dissolved constituents pictured here is the fundamental relationship that underpins our approach to MRV. So how dissolved sort of parameters that we can measure in the carbonate system correlate to CO2 consumption is kind of exactly where we're going with this. But a bit more about our research approach. Our main MRV approach relies on taking these measurements with precision and demonstrating that these correlations between changes in the carbonate system and carbon removal rates are true based on a succession of scales, from beakers in lab-based experiments to benchtop experiments, and then finally in natural ecosystems in our field trials. So we've conducted a series of lab-based tests under EPA protocols around ecotoxicology and environmental safety and dissolution, and we're now moving into field work. We have a very integrated research approach with quite an interdisciplinary team of expertise spanning across the space to really help inform how to deploy these projects in a way that is measurable and also will be effective for our carbon removal goals while staying safe ecologically. We have a number of other collaborators that are supporting our work. These scientific collaborators are just a few select ones and an incredible team as well. That team is comprised of 12 PhD scientists that are really building out this framework and developing the roadmap for us to evaluate coastal carbon capture, the risks, benefits, and opportunities of it. And then we've developed this structure to ensure that on the basis of this research, we can ensure that there's a mechanism for scaling to impact if it's warranted. So our corporate structure is a hybrid one. We have a relationship with a 501c3 fund that funds the charitable research that we do in the field of coastal carbon capture. And we also have a public benefit corporation, which is developing the technology, supply chain partnerships, and commercial plan for scaling. Now, the process of coastal carbon capture is depicted on the right here. And what I have highlighted is measurement, reporting, and verification, which absolutely is critical to unlocking our business model and scaling our climate impact. Now, as there are no verification agencies that currently have a methodology for ocean alkalinity enhancement or our specific application of coastal carbon capture, we are developing our own methodology to be submitted to verification agencies. So to kind of give you the really high level picture of what it is we're doing, not unlike many other nature-based solutions, our MRV methodology path relies on measuring key parameters in the lab and in the field that we can. and that we know constrain the system and can be correlated with carbon removal. So for trees, models can be used that plug in pixels of data from satellite imagery or measurements in the field. And we do a similar thing, but we're trying to do that for the ocean instead of in the forest. So we're using field and lab measurements of changes in the carbonate system that can be measured using sensors and geochemical analyses of samples. And then we plug those into models. So here you'll see we combine a mechanistic model that we call radio of olivine dissolution and carbon removal in the sediment column, and overlying seawater with empirical data that's collected in the lab, microcosms, mesocosms, field deployments, and natural analogs. I'll share a bit more about that in a moment, but the collection of data in the lab and in the field is what's going to allow us to improve the accuracy and the reliability of this model. So we'll start with very conservative buffer pools and then refine those pools once we have additional data that's been evaluated and peer reviewed. So once that data is parameterized and validated, the models will help us to constrain these carbon removal rates. And then that model can be integrated with more complex regional and global scale models like the Earth systems models that can quantify impacts on carbon storage that occur across these larger spatial and temporal scales, as Mowgli was pointing to. So specifically how we are doing this, we measure the addition of alkalinity to seawater through olivine sand. We can measure that in changes in pore water, so the water that exists in between the grains of sand in the ocean. There's a longer residence time, so water stays for longer periods of time in the pore water than it does in the overall ocean seawater. So we can take better measurements in that pore water, and we can also measure changes through a variety of other instruments. So we then take those measurements and can then convert that change to the relationship of PCO2 change, which is established really well in academic literature, and then confirm that with constrained experiments. Then as carbon dioxide leaves the atmosphere and enters the seawater, we can, again, control that well with the established academic literature, confirm with our experiments, and then couple that with ocean circulation climate models to calculate when and where carbon dioxide leaves the atmosphere and enters the seawater, and then calculate the long-term effects on carbon dioxide into the atmosphere. These are the experiments that we're doing and the models we're building. I mentioned them just briefly, that we're using sensors and geochemical analysis of samples, and then this series of experiments to build these models. We've just deployed some of the first ever field studies. So actually the first field demonstration sites of ocean alkalinity enhancement this year. Our first project was in collaboration with Woods Hole Oceanographic Institute, the U.S. Geologic Survey, and the National Park Service in a wetland environment where we did a very small pilot experiment there. I'll share some of the preliminary results from that in a moment. We also completed a field analog study in Papakolea, which is again a natural analog, a natural olivine sand beach that we've been studying. And we deployed a coastal carbon capture site in Long Island, New York, where we worked with a coastal community that had a continually eroding shoreline and replaced a portion of that project sand with olivine sand for that beach nourishment. So all of these happened this summer, and we're really excited about some of the preliminary results there. Looking forward into 2023, we have a couple of other small experiments planned and a nearshore placement plan to continue the research and continue gathering data in the field. So just briefly to touch on some of the results from our Herring River Salt Marsh site in Massachusetts. We're seeing some really promising results here, seeing a sustained increase in seawater pH. What you see here is that 1 day post placement and then into a month post placement, we're seeing places where there's more olivine, there's a larger pH effect. Again, this is preliminary, but we're excited about some of this early data. And then in Long Island, we're also seeing some similarly exciting results. So the top chart here is showing pH changes, and the bottom is a similar chart, but alkalinity, which is again what allows us to understand the carbon removal reaction. And pictured in the center is the benthic flux chamber that we're using as well to isolate and analyze changes in seawater chemistry. So we're definitely seeing increased pH at both sites, which again is required, but not sufficient evidence for carbon removal. We're modeling the results of alkalinity and using the data that we have at the moment, which suggests that we are capturing carbon at the rate predicted by our laboratory experiments. But we're still in the process of analyzing the alkalinity samples, which will hopefully confirm these modeling results. Now, on the path to registry verification, this is again a very high level and not nuanced explanation of kind of our path, but the first step for us is developing our MRV protocol to our level of kind of satisfaction and understanding, and the sort of scientific community's level of satisfaction. And then submitting that protocol to different independent entities for third-party validation, and then to registries like Vera and Gold Standard. There's a series of, obviously audits and project reviews after that that come from the registry, and we also anticipate that this methodology will be iterated on and refined with additional field data. But something to kind of point to here is the fact that there are unique customers kind of at every level on the path towards methodology verification, especially noting that it's a long one and it takes a sustainable business model to get to scale. Vesta and many other ocean-based removal companies are thinking about how to best participate in the voluntary carbon market in a way that is rigorous, honest, transparent, but also allows for agility when methodology verification is, again, a very long process. We are submitting our first concept note likely at the beginning of next year, and we have a goal for accreditation by 2025, assuming good data and a proper peer review process. But on the path to that, we have pre-sold some credits to Stripe and to a few small corporations. We're selling credits rather from our first deployment on an ex-ante basis, where we have entities essentially pre-purchasing a forecasted carbon credit, which is something that's very commonly happening in the early stage carbon removal space today. But again, the elements that are really important here, we believe, are transparency and rigor. So we're trying to be incredibly transparent about our process here. Yeah, I think the one thing I would say I actually disagreed with Mowgli on is that his point around MRV not being something that is necessarily central and called for in the carbon credit space. I just left Climate Week, and I would say that it was one of the words I actually heard the most. Like a lot of people, buyers and other folks in the space are turning a close eye to MRV. And everyone really wants to be sure that that trust and transparency can be built into this market if it is to scale and achieve the kind of climate impact that we all want it to. And the last thing I'll say is that we do have an internal code of conduct. So Vesta developed our own code of conduct after a review of code of conducts in adjacent spaces and came up with our own as the overall field is developing larger codes of conduct to sign on to. We continue to seek input on it, and we plan to actually publish it for public comment very soon. But the one thing I want to highlight here is that we're really indexing on transparency and oversight by partnering with independent academic scientists, both through academic collaborations and through publishing our research in peer-reviewed journals, which again is in part why we are working through a hybrid structure. This is not just ethics, but this is also to provide a framework for coastal carbon capture as a solution so that if other organizations would like to deploy and or license our technology, eventually there's a framework that can be followed by all. Thank you so much, and excited to get into discussion.
Thank you so much. That was really amazing and interesting, and glad that you raised that first hot topic or question with Mowgli. And that comes to, before we get into some of the comments we are receiving on the Q&A, which I'm not sure whether you can read that, because that would be much easier for you to understand what people are asking. Let me ask a question regarding what just Kelly raised regarding Mowgli's comments, which is it's just a general feeling. Do you think we are asking the same level of rigor in terms of environmental impact to blue carbons that we have been doing in the past for land-based carbon sequestration? It's for any of three of you, maybe Mowgli, we should be more appropriate, because you raised the question of the environmental impact of CDR. And my question is whether we are doing the same profile of analysis. Of course, the ocean is much more complex than the land side, probably, but are we requesting the same level of rigor when analyzing those collateral impacts? What's your view?
What do you mean by are we requesting? I mean, this market is completely unformed. I think what Kelly said is true. Everyone is talking about MRV, and everyone would like to see good MRV, and people are also talking about the need for ecological impact assessments, but there's no authority, there's no one in charge to be requesting those things. I think we're all just sort of hoping for them. Do you know what I mean?
Sure, absolutely. No, the point is that, well, first of all, let me say that I haven't mentioned that when my introduction, I'm listening, speaking on behalf of the World Ocean Council, as there's a business community that's moving the maritime economy into sustainability. And of course, blue carbon is one of the hot topics being on the table. And one of the things that the business community is requesting is how can we end up setting all those different standards that we can really get this 10 times more amount of CO2 that can be sequestered by the ocean, and of course then mobilize those resources that can be light. So just having said that, yes, what I meant was specifically that concern on environmental effects that are being raised, and we are seeing that they're generating. It's probably one of the most difficult areas so far to really be able to develop this blue economy, this blue carbon credit, etc. I don't know whether you were able to read the Q&A we are getting read, because there's one very specific being asked by Jeffrey Annelsey, sorry if I'm not pronouncing the name properly, which is to Kelly. I don't know where you can see it, Kelly. You want me to read it? It's in the Q&A post. Do you have access to that? Is the third one? It's on a specific. I can read for you if you cannot.
I can answer it in the chat.
Sure. Or if you want to comment on that, or just you want to wait and get into if you want, as it is very direct, just leave you some time to think about it, and I'll get to Mowgli again, because he was this comment on Jeffrey, turning on the issue of customers of carbon credit demanding MVR verification. Can you have a comment on that second message from Jeffrey, which was posted while your introduction?
Yeah, so he's saying that buyers are not going to spend their money without a guarantee that they're going to get what they paid for. Again, I think we all hope that that's true. I think that, you know, in the legacy markets, we've just seen the ways in which market forces played out in a way that didn't demand good MRV. And so I think in a way, it's going to be hard to institute a new system that does structurally require good MRV without taking a hard look at how things went in the past and understanding better why so many carbon credits that were sold in the past didn't really reflect actual carbon storage. You know, we have to think about what went wrong there, and how we can do things differently. So in theory, no one's going to pay for something without a guarantee that they're really getting what they paid for. But in practice, as the markets spread beyond these early buyers, and you have more of a retail market for carbon removal credits, we just need a lot of structural things in place. You know, the kinds of things that Vera could put in place, or that Frontier could help to put in place, to ensure that MRV is really robust. And as we get into the oceans and into places where things are harder to measure, putting those into place are quite hard. You know, how do we do ecological impact assessments in an ongoing way? How do we have third parties come in and, you know, not just generate estimates of what the ecological impacts will be in the future, but do regular assessments to make sure that things go the way we thought they were going to go. You know, we just don't have those structures in place, and we have to make sure that we put them in place. And I think the lesson from the legacy markets is that a lot of things can go wrong, and there's a market demand for lower cost credits. And you know, how do you set a floor in a market system where you know, certain credits that don't meet these standards don't reach the market? We just need to put all of those structures in place.
Yeah.
Right.
I have two comments to add to that. I think while it's true that there may not be a regulatory requirement for MRV in the voluntary carbon market, it's also true that many early stage carbon removal companies are likely going to rely on at least some level of federal funding or government funding to try and scale and develop their technologies. And more we're seeing MRV as a critical underpinning to the applicability for any technology company to be able to receive that federal funding. So to that degree, I think we are going to be moving more towards there being a requirement, which is more of a market force than anything else. And then the other thing to just note is that I think, you know, Mowgli, you were kind of getting to this just a moment ago. There needs to be certain floors and regulations around standards of quality before a credit is issued into the market, and there's a lot of change happening in that regard. And it's important, I think, to evaluate any carbon removal solution on a matrix of costs and benefits, right? And it's pretty much the case that for most ocean-based solutions, MRV is one of the bigger costs. MRV is harder to do in the ocean, and for other types of CDR solutions, there are other drawbacks like energy efficiency and, you know, industrial requirements and non-permanence. And so buyers in the market today are burdened with having to figure out that risk matrix themselves, and then develop their own portfolio approach on the basis of what's best for them. And I do think that, you know, from a market making perspective, it likely would behoove everyone to try and build in some differentiation or price in these different elements that are cost and benefits of different solutions.
Yeah, I mean, you know, people have talked about structuring pricing for carbon credits in a way that's more granular and accounts for, you know, people have talked about putting a clearer price on permanence, so that you know, that carbon credits that have greater permanence have more value. And that, I think people in the carbon removal markets see that as an obvious thing to do, but in most of the active carbon markets right now, there isn't a clear way to even price permanence. And so things like that need to be structured in. Pricing uncertainty needs to be structured in. Carbon credits that have good MRV need to have more value. So I think we're moving towards a market where it's harder to commoditize carbon in a way that applies across lots of different methods, but where different kinds of credits have these different attributes that provide value, and good quantification, you know, will be one of those attributes, ideally.
Kelly, do you would like to jump on this on Jeffrey's comments? He was asking.
Yeah, I can answer that in the chat just so we don't spend too
Okay.
much time in the weeds. I think we have some pretty great questions in the chat.
Great. So then let's jump to one of the questions we have here is, why does accreditation of carbon credits take so long? It seems it takes a few years to do so, and it's seriously discouraging. Any comment on that, Liz? Maybe that's your turn.
Yeah, absolutely. I can take that question and at least speak to the verified carbon standard and Verra's work. So I think what you're getting at is less so the accreditation of carbon credits and more the entire process of developing a carbon crediting methodology, which does take anywhere from 12 to 18 months. And that's because, at least within Verra's systems, we have a very rigorous methodology approval process whereby first a methodology is proposed to Verra. It undergoes an internal review by Verra staff. Then that methodology is actually shared for a stakeholder consultation where any external stakeholder is invited to submit comments and feedback on the methodology, which then leads to generally another review process. Typically in these consultations, there are comments received from various academics, NGOs, private sector as well. So it's a pretty varied type of feedback that we receive. And then following that, the methodology itself is assessed by one of these external auditors, so a validation or a verification body. And by going through this very rigorous process, we essentially are able to find where there is agreement amongst academics and where there is also agreement amongst other stakeholders who are experts in that particular area. And so the methodology that is ultimately available for use is a very rigorous approach. And so that developing that accounting methodology with good reason does take a good amount of time. However, once a methodology is actually ready for use, as soon as it goes online within Verra's systems, a project could be developed. There can be, of course, time and efforts going into actually developing a project, which I can't necessarily speak to, but I think that the length of time that it takes to actually get one of these methodologies online is appropriate and speaks to the rigor of that is required for an accounting methodology to then be used to actually generate a carbon credit.
I just want to say, I think it's really frustrating to people how long it takes, but we should accept that as the price that we pay for the rigor that we need to have in the system.
Yeah, I would agree, and I think that there's definitely room for you know, maybe evaluating where there are places where we can expedite processes by, like, you know, adding additional staff or additional experts and things like that. And that is notwithstanding the fact that, you know, this is a nascent field that's growing really, really rapidly, and everyone has their own constraints, including, you know, organizations like Verra. I'll just say from the practitioner side, I think it's unfortunate that there is some sentiment in the field of people sort of not thinking that we need to reinvent the wheel, or that entities like Verra and the gold standard shouldn't be the sort of ones that are consulted for this. I think that there's a lot of good and a lot of expertise in these agencies, and so I think it's important that we figure out a way to work within the constraints of the system, where we do need to move with agility, but we also need rigor. And I think as a overall field, we need to be aware of where there are places where methodologies may be cropping up that are less rigorous. I would just say that one of the worst things that we could do would be to advance techniques that are not transparent and not rigorous, and therefore degrade the trust in this market that so much needs trust. We need to be able to build our business models on the basis of carbon credits so that we can actually anticipate global climate impact. And we won't be able to do that if trust is degraded in a way that collapses that very market. So rigor is super important here. And I don't think we've quite gotten there on balancing the need for rigor and also movement forward. So just.
Thank you. This brings to Aaron Coulson question. Is first thanking all for the terrific presentation. So the question being is, who will accredit or govern third-party MRV certifiers? This probably Liz again.
Yeah, again, I can just speak to Vera's system and the process that we have for accrediting validation verification bodies. And essentially, these VVBs would need to be accredited by an international accreditation forum that follows ISO standards. There are various accreditation standards. For example, within the US, you have ANSI, I believe it's the American National Standard Institute or something along those lines, but I can drop in the chat or share more largely the different rules that we have within Vera's constructs to become an accredited VVB.
Thank
And
you.
I should just say that,
Sure.
in the absence of international accreditors who can oversee and accredit MRV entities, international bodies like that don't necessarily have expertise yet in ocean CDR, right? And so at the moment, I think there's a gap there. Until those international bodies are skilled in this field, it's critical that anyone who's doing MRV, either as a project developer or as a third party, be absolutely transparent with their methodologies. And that means publishing what they're doing. It means being transparent about what models they're using, how those models are parameterized, and making all of that data and all of that methodology public so that the international scientific community as a whole can weigh in on it.
Yeah, agreed. There are some sort of independent ratings agencies that are rating methodologies and rating the auditing of projects and things like that, which are cropping up. And from a broader, like, high level picture, I think it is an interesting thing to watch of just the overall development of the space and whether the world will contract into less agencies or continue to grow into this somewhat alphabet soup reality that we live in right now.
And keeping on that topic, let me ask something. We are seeing, from our perspective, we are seeing the business community extremely interested in all around blue carbon. And as we said, the world needs ocean CDR. What do you think, from your expertise perspective, this business community can do to help you out, to unlock all these amazing blue carbon opportunities, as Molly was mentioning, and let's say accelerate this process, or as Phil Keel was asking in the chat, how do you see that the business community can enhance and help unlocking this and speeding up all those processes so that we can get to a larger scale? Any of you would like, what can the business community do to do that?
I can speak a little bit to get things started. I think that there's a lot of need for more empirical data in terms of the actual greenhouse gas benefit of the different types of interventions that are being proposed. And so if the private sector can help to support that data collection and research and really feed into the R&D, then I think that can help to advance these opportunities such that they become creditable. And then there is the sustainable finance mechanism that can continue to fund their implementation and then hopefully scale up climate change mitigation.
Any additional comments?
I mean, the mechanism we have in place now is this advanced market commitment or pre-purchases of carbon credits, and that's been really, really powerful. It has also, I think, there's a subtle way in which it's confused things, right? Because when you're pre-purchasing carbon credits, you don't need MRV. Those pre-purchases are coming from entities that are essentially investing money in R&D, and there's no way to do MRV. But we have seen instances of companies that have pre-sold credits, then putting credits of the same nature directly on exchanges, where companies or individuals with less expertise can buy them directly. And I think that is a problem. But at the moment, the advanced market commitment and pre-purchase mechanism is really powering the field. And And I think we should be grateful for it.
Yeah, I would double down on the power of the advanced market commitments. I think we need more of them. And I think that there are ways that they can be constructed such that MRV is a necessary feature of payment, right? So structuring an advanced market commitment such that, you know, the first payment in that commitment only comes when a technology or a project developer has received accreditation, but they have the commitment for that purchase in advance, so that entities and technology companies can go to financing parties and get these projects deployed so that we can get data in from the field. I think advanced market commitments are really great tools for that. And there are ways that they can be structured that ensure both sides of that commitment, and also can ensure that we're including MRV in the process.
Thank you. I'm not seeing more questions, but let me ask you before we get something else and we run out of time. Any thoughts about whether the digitalization and all these different initiatives we are seeing around tokenization of nature can play a role in speeding up this process we've been talking about? Any views on that?
The tokenization of nature as opposed to the sale of carbon credits?
Yeah, as a way of selling carbon credits through a blockchain and tokenizing these kind of initiatives, like an alternative market.
You know, I can't really speak to that, but one thing related to it that I will say is that in the effort to promote high quality, high integrity, transparent voluntary carbon markets, and there've been a lot of different efforts to do that, including the Integrity Council for the Voluntary Markets and groups like that. There has been a lot of focus on the transparency or traceability of the credits themselves, the transparency of the way the finance moves and the way the credits are transferred, and a lot of those efforts have ignored the technological underpinnings of whether the carbon is really stored anywhere, and they've focused on the sort of flashiness of making sure that the paperwork is on the blockchain. And I'm sure that has some value. But if you have a credit that was never technologically measured well in the first place, it doesn't matter how permanent it is on the blockchain. And so I think many of those efforts would do well to look at the very base of their supply chain in the first place.
Yeah, I absolutely agree with that. I think the use of blockchain technology is really interesting for companies that have yet to receive registry verification. If they're still using methods that are being third-party evaluated, or are being transparent about the measurement practices that they're taking, and would agree that the majority of those efforts that I've seen on the blockchain are more about the use of the technology rather than the rigor of the measurement.
Thank you. We have one final question. Is there a case to be made for advanced market commitments for MRV itself? This is from Aaron Cozen.
I think so, but it's very hard to structure that, right? Advanced market commitments generally go to project developers, and I think it's been hard for anyone to see how, for instance, a group like Frontier would directly fund MRV. But I think that is sort of the basis of Frontier's proposal, that a price be put on uncertainty reduction. And so I think that's the way that advanced market commitments can fund MRV, is that those advanced market commitments put a price value on lowering uncertainty, and therefore through that mechanism can funnel more money to projects that are doing good MRV. I think that's the mechanism that people have a view towards right now. and it's hard to see a better one at the moment. Kelly, Liz, do you see any other way?
I would say that's right. And one could imagine there being some kind of forward commitment for an MRV technology company to do the work it's going to do, but that's a lot of nested bets, including the one that company has a whole pipeline of customers that are currently developing their technology. So I think Mowgli, you hit it on the head.
Yeah, I agree with that. I think it's a bit abstract to actually quantify carbon credits pertaining to an investment in MRV, but do agree that it is important and agree with you on that, Mowgli.
Okay. Okay, but we don't have any further questions here, and I think we are already at the end of the session. Will, correct me if I'm wrong. Is that correct? Okay, so now it's time to really thank you for this amazing presentation and conversation we've had. It's been really outstanding. So thank you so much for your time and effort and for being here and sharing those thoughts and comments with us. And thank you, Will and Jen, for the invitation of hosting or moderating this amazing panel. It's been a pleasure. And let's see if we can all together unlock and boost all this blue carbon, because I haven't mentioned that, but it's one topic we haven't talked about. It's the amazing potential for funding ocean restoration that blue carbon can get. So we better move that forward, because if we can unlock all this enormous potential that Mowgli showed, this 10 times more than 100 times more lasting than the land side, the resources we can get for restoring the ocean are amazingly high. And as once Alexandra Cousteau mentioned, there's more value in regenerating what we've lost than keeping what is left in the ocean. So we get above for it. Thank you so much.
Thank you.
Thank you.
All right. Thank you, everyone. And I'd like to encourage everyone to join us tomorrow for the second part of the conference. We have two panels tomorrow. The first will focus on CDR developments in the UK and in the European Union, right, where some of the approaches are very different than what we're seeing in the United States, and it's a good comparative analysis, I think, of CDR policy. And then our second panel, our final panel, will focus on federal and state legislative activities in the context of carbon storage, right? And this is a highly dynamic field. There's a North Dakota Supreme Court case very recently that struck down state legislation in terms of pore space ownership. And that may sound really in the weeds. It is, but it can be a critical consideration in terms of the speed of permitting of storage and the costs associated with it. And obviously storage has relevance for a lot of the CDR approaches that we're thinking about, including things such as DACs and BECs. So I hope you will join us for that. And with that, we will close the first day. Thank you very much for coming. Hope to see you tomorrow. Bye now.